Can everyone see my screen right now? You should see a slide that says, what is programming? Cool. All right, so we'll get underway here. Um, so the way that we've designed this two-week curriculum, like I said, we want to make sure we cover maybe not in as much depth as we want to, but we want to kind of go broad and make sure you understand what the basic components of basic front-end software development is. And to do that, we need to cover a lot of kind of not even, we're not covering, like one thing you really quickly realize that programming isn't just one thing, right? Programming in reality is just another way of saying problem solving, right? But it doesn't actually kind of tell you a lot about the exact things that you'll be doing. And there's many different blocks or types of things that you'll be doing. Over these 6 classes, the way that we've laid it out is on the first day, so today, we'll be talking about HTML, which is kind of the way to build the core elements of a traditional website. Tomorrow we'll be doing a day on CSS, which is a way of designing and making the websites look prettier. And then for the following 3 classes, so this Wednesday, next Monday, and next Tuesday, we'll be covering an introductory session on JavaScript. JavaScript is probably more what we consider to be traditional software programming in the sense that it's a little bit more algorithmic and we'll be doing more problem solving. And our goal is by the end of these 5 classes is that you'll be able to see how these different parts kind of fit together to create what we think of as a typical website. And then on the very last day, we'll be having you guys do a problem that puts all of it together, right? So it's no longer just do something for me in HTML or do something for me in CSS. It's like, hey, build me a page that does these different things. So once again, today's HTML, tomorrow is CSS. Days 3, 4, and 5 are all sections on JavaScript. And then on day 6, you'll put everything together and build kind of a mini website website by the end of it. So what is programming? The first bullet is actually something that you'll actually see quite more of in JavaScript than you will in HTML and CSS. But really, programming is about taking an idea or taking a piece of information, doing something with it, and then giving us back the output, right? If you think of most traditional software or computers, really, the idea is, I input some words and it gives me back like a printed piece of paper, right? Or if I give it some numbers and it gives me back the sum of those numbers added together. Like I said, this is probably more on the JavaScript side, but this is kind of the taking information, transforming it, and then giving you back the result. That is fundamentally what every software program really tries to do. It involves a lot of logical analyses and decision making, and it's very repetitive. The thing I'll say here, and this is something that is actually it's a concept that I'll repeat a lot throughout this course, because I think it's one of the kind of mental adjustments that people have a hard time making if you come from a non-computer or a software-based background into this field. And that's basically this idea that computers are great at doing very structured, very complex things over and over again with extreme accuracy. Okay. On the other hand, what they are not good at is handling very ambiguous problems without a well-defined process. And so if you really think about it, a human and a computer, in a lot of ways, they're kind of diametrically opposed, right? Humans are actually very good at handling vague, ambiguous directions. But if I ask a human to do something 1,000 times, more likely than not, they're going to have 1 or 2 mess ups, right? On the other hand, for a computer, they're actually very good at being very precise. If you give a computer an ambiguous thing, it wouldn't know how to handle it, and it can do something many times with a high level of accuracy. So one example I really like that helps describe the way that a computer handles ambiguity versus a human is that if someone asks you a question like, who is the 8th president of the United States? Well, if you don't know the answer off the top of your head, you might just tell that person, just Google it, right? And if I say just Google it to another human being, at least in this current era, I think most people kind of know what that means, right? It means go to a computer, open up your web browser, put in Google, type it in, who is the 8th president of the US, and look at the answer, right? But realize that all you've really said to somebody is just those 3 words. You haven't really provided a clear set of directions on what to do, and what you're doing is you're leaving it to the other human being to figure out, oh, there's all these different steps I need to take, and I should know that. Okay, so if I say just Google it to a human, that sounds like a perfectly clear set of directions. If I say just Google it to a computer, the computer is going to have no idea what to do, right? I need to actually tell a computer, hey, open up this browser, go to the URL bar, type in www.google.com, type in this search or this query, and then look at the first result or look at the answer box to get what we need, right? Two very simple things. But once again, with a human, we can afford to be a little bit more ambiguous. With a computer, we have to be really, really, really precise. Why is this important? Is because when people first start writing code, they like to write ambiguous code. They like to think that, well, hopefully the computer is going to know that I mean for it to do this, right? And the answer is no, the computer is not going to know what you mean to do, because computers don't really interpret, right? They read the exact commands that you give it. And if you don't give it the exact command, then the code's going to fall apart. One of the most common issues that I kind of see when people first off programming is that they kind of give a computer vague directions, and the funny slash the catch is that they don't actually themselves quite understand how the code is supposed to work. They just write something and they hope that it does work. And when it doesn't, they're kind of stuck. And so one of the things that I'll be make sure to pushing kind of us as a group really hard on is when you look at code, when you write code, when you problem solve, always be very, very clear on what you're doing. If you can't describe what you're doing, there's no way a computer is going to be able to figure out what you're trying to do, and everything's going to fall apart. And then the last two bullets kind of wrap into this idea that people think of computer programmers as people who are locked in a room with an energy drink, with the lights dim, kind of by themselves for like 18-hour binge sessions, right? And that does happen occasionally. But if you think about any kind of worthwhile software that's kind of been built nowadays, whether it be Facebook or Google, or even something as old as, an old banking terminal, right? Those are behemoth projects, right? They're things that no human being can do by themselves over the course of a lifetime, much less days or months or even years, right? Any piece of software really worth building is done through teams and collaborative effort. And one of the other more common questions I get whenever someone does something with programming is this right? Well, my counter to that question is always, well, does it work, right? With programming, you actually notice that one thing you'll very quickly realize is that there's no quote unquote right answers. There's almost usually multiple ways to do the thing that you want to do. And yes, some solutions may be more efficient or more elegant than others, but it doesn't make the other ones wrong. Okay. And so programming is not meant to be there's an only one right answer and you get to it by doing it yourself. Very often programming is there are multiple right answers, and so you want to pick the one that at least makes the most sense to you. And then you need to be able to collaborate with other people to build bigger and more complex and more robust projects. It's the reason why, if you look at any developer at any big company, right, very rarely are programmers working by themselves. They're always working with a team. And that's just because whenever you build anything, if I go to Facebook, for example, and I build something, Facebook's not going to say, oh, great, David, let me just relaunch Facebook, but now with just this thing for you, right? It's my job to understand what other people have previously built and build something that integrates well into the Facebook ecosystem. And so and hopefully one of the things that's going to jump out at you over the course of these next 2 weeks is just how much of programming, it's not just what you build, but it's can you make what you build work, but also fit into the context or the code that's already been written. So like I said, over the next 2 weeks, we'll be talking mostly about HTML, CSS, and JavaScript. When you think about the basic setup of a website, one analogy we really like to think about is the idea of a human body. And I'll talk about what that means in just 1 second. So HTML stands for that thing that you will never need to know ever again. So we'll just keep going through it. And what HTML really does is it provides a way to organize kind of the physical elements. And I use the term physical very loosely here, but it's the thing that actually creates the pieces of a website that you see, right? Whether it be a picture or a box or a line of text. Like HTML is the thing that actually creates that. And CSS then becomes the way to make those elements look pretty. HTML allows me to create a line of text. CSS allows me to change the font, maybe change the font color, maybe change the font size. It's all the things that I can do to dress up the HTML that I've made. And so it's more of a visual component. And then lastly, we have JavaScript. And this is a way to make the code more interactive. This is kind of where the I would say the intelligence of the website really comes in, because JavaScript allows you to create very complex functions that not only kind of do something, but it can also interact with the user. if you ever hovered over a button on a web page and a menu dropped down, right? Like that's JavaScript, more probably JavaScript, right? And that's a method of interaction, because what you're saying is if the user does this, then respond to the user in this way, and so on and so forth. And so JavaScript is kind of the intelligence layer for a traditional website. So the analogy that we usually give in terms of human body for making a website is the HTML then becomes the skeleton of the website. It's the raw component. It's the backbone. It's the pieces that really hold the website up. The CSS then becomes the skin and the clothing. It's the things that go on top of the HTML that make it look prettier. And then the JavaScript becomes like the brain or the nervous system of the website. It's the thing that makes it more intelligent or smarter, or kind of able to do higher functionalities. And so hopefully by the end of these 2 weeks, you'll get a good sense of what all three components are about. Any questions? Everyone good? Cool. So like I said, today we'll be talking about primarily about HTML, which is the skeleton of our website. Yeah, so today we're going to talk about how you see the output of your HTML code when you write it, the syntax for writing HTML blocks or HTML elements as they're called, and then we'll go through some of the very, very basic elements. There's literally hundreds, if not thousands, of elements in HTML. So we really stress that all we're trying to do is get you to look at the most basic, the most commonly seen HTML elements. And then we'll talk about adding additional information to these elements through something called attributes. And this applies both to text elements as well as images and links as well. Okay, so on the left-hand side, I basically have this web page that looks fairly standard, right? It's something that I could go to, any blog or any website, and I would see something like this and wouldn't feel out of place. I have my header, I have my text, I have some images there too, and this looks pretty clean. But this is the output. This is what I see as a user. This is not what is actually used to kind of build out the website. Instead, this is what the website looks like when I look at it through the lens of HTML, or really just kind of the raw kind of component aspects of it, right? And it looks very different. But if we just squint and take a little bit of time looking at it, we can actually kind of see how the components more or less line up, right? We see a lot of the text that we see on the left-hand side, on the right-hand side too, except now we notice that they're ordered in a certain way. And so what we see on the right-hand side is HTML in its purest form. And all HTML, like we said before, all it does is it creates the bare elements or the components of the web page. So if I have a line of text or a block of text, that's an element. If I have a paragraph of text, that's another element, and so on and so forth. And so if we look on the right-hand side in this box here, every element in HTML, and we'll talk about one or two exceptions here, but more or less every element in HTML has what we call an open tag and a closing tag. Okay, a tag, it basically just denotes where the element starts, and the open tag tells you where the element begins, and the closing tag tells you where the element ends. Okay, the tag then is just the carets, the greater than symbol and the less than symbol. And so if we look at the first line on the right hand side of the box, you'll notice that it's a open caret, we have the text body, and then we have a closed caret. That then is the opening tag for a body element, or a body container as we call it. Okay, we only know what body is for now. Just know that it's a tag and it holds information within it. Okay, if we look on the very last line on the box on the right hand side, you'll notice that it's another tag, except this time it has the open caret sign, but then it has a backslash followed by the word body, and then a closed caret. And so that piece is what we call a closing caret. Sorry, a closing tag. So between line 1, which is a open body tag, and the last line, which is a closed body tag, those two things form the bookends for the body element. Okay, and this is kind of how we write HTML. It's that every element is just an element with things either inside of it or it's inside of other elements. Okay. In this case, a body tag actually doesn't do anything. It's just a catch-all. It just tells us, hey, this is where your website starts and where your website ends. But if we look at line 2 here, we'll start seeing how the elements actually are able to actually create the output that we see in the page on the left. So if we look at line 2 here, notice how for the first thing that we see is the open caret h1 close caret. Okay, and so this tells me that I'm now looking at an h1 tag because that's the text that's in between the open and close carets. And I know it's an open tag because if I look at the end of line 2, I see the same thing except now h1 has a backslash in front of it. That means that this is a closing. That means that this is a closing h1 tag. And so whereas the opening tag tells me where the h1 element starts, the closing tag tells me where the h1 element ends. And in between, in black, I have these text of how I learned to code. What does h1 stands for? The H in h1 stands for header. It's a way for us to create a big, bold header on a given page. And so if I look at the page on the left, I can see that the words how I learned to code is in big, bold letters. And so what the HTML on the right-hand side has done is it's saying, hey, take this text, how I learned to code, make it the content or put it in the middle of these h1 tags. And what the h1 tag will do is it will take all the text that's inside of it and it will print it out on the page, but it'll do so with a larger font and a bolder font too. Okay, and so that's very simply how we create the header on the left-hand side is through the h1 tag. Does that make sense, everyone? The very beginning is the hardest part, but once you start seeing one or two of these, hopefully the pattern is going to start jumping out at you. If that's line 2, then on lines 3, 4, and 5, notice how on line 3 we have what we call simply a p tag, right? It's an open and closed caret with a p in it, and then on line 5 we have a closing p tag, right? It's still an open and closed caret with a p in it, but now there's a backslash in front of the p. That tells us that this is where the closing tag for the paragraph element is. And in between it, we have this line of text. Now, on this page, notice that the ... after AMET, right? That just means we're abbreviating it. But what the P stands for is P stands for paragraph. So whenever you write multiple lines of text in a paragraph format, a P tag will be used. And when we have a P tag, we write the P tag and we just put whatever text we want to put in the paragraph in between the tags. And so notice how there's also this kind of vertical spacing element, right? On line 2, our first line is how I learned to code in big, bold header text. And indeed, that's the first line of text on the left-hand side. The next element on down is the P tag, and it says, hey, take all this text and put it in a paragraph format. Well, when I look at the site on the left, that becomes then the second paragraph, right? That's the first paragraph that we see that's the first paragraph that we see. It's the second block of text that we see. If we keep going down more into line 6, we now see a tag called the H2 tag. The H in H2 also stands for a header, but what the 2 indicates is that this is a header tag as well, but this is smaller than the H1 header tag. In HTML, what the header tags do is that there are 6 levels of headers: H1, H2, H3, all the way to H6, and as the number gets bigger, the header gets smaller. And so in this case, when we see our H2 tag, what that tells us is we still want to make a header tag that's bigger and bolder, but it's going to be slightly smaller than the H1 tag, but definitely bigger than the paragraph text, right? And when we look at line 6 there, when we look at our H2 tag, we see our H2 tag, and in between it, we see the text step 1 HTML. And when we look on the right-hand side, on the left-hand side, we see the step 1 HTML text there as well. Beneath the H2 tag, we have our P tag, so our paragraph text for another block of text. And then last but not least, we have our image tags, right? We'll talk about image tags when we talk about attributes and linking for now, because the image tags do look a little bit different. But at a very high level, does everyone kind of see how the HTML on the right-hand side translates into the visual page that we see on the left-hand side? Are there any questions here? Okay. So just kind of as a quick recap, then when we talk about elements, right? These are the components. These are the pieces of these are the things that actually show up on the web page. So the most common one, or not one most common, the most common one for showing a long piece of text is once again the p tag, which stands for paragraph. On the left hand side, we have our open p tag. On the right hand side, we have our closing p tag. And so this bookends the boundaries of the paragraph, and then whatever text we put in between it, that's going to show up in the paragraph. Similarly, we have our h1 tag. So we have our bookend starting or our open h1 tag as well as our closing h1 tag. And notice how in both cases I put the text high exclamation mark in between them, but the h1 tag renders a high very large and very bolded, and on the p tag the text shows up as a very small, very plain text. Lastly, we have this thing called the image tag. And the image tag is a little bit different than other tags because if you think about it, if I have a paragraph text or a header text tag, I need to tell that paragraph or that header what text to put inside of the content. With an image, I need to tell it what image to put, but the image in this case would be stored in a location somewhere on the computer. I wouldn't need to kind of use text to draw out that image, nor would I need to put anything inside this tag besides just the location of the image. And so because of that, the image tag is what we call a self-closing tag. There's very few of these, so this is more of a rare format. But just notice for the image tag, we have our open caret, we have img, which tells us we're looking at the image tag. And then on the right hand side, we have our backspace, and we have our closing caret. Okay, this is a self-closing tag, which means that whereas for the P and the H1, we have bookends, right? We have a start tag and a finish tag. For the image tag, we just have one tag, and that one tag is self-closing, so it ends in a backslash. And also in the image tag, we have this attribute called src. We'll talk about what attributes are in a minute, but for now, just know that the src is gonna tell the image tag where the location of the image is, and when we say src equals, and then we're gonna put the location of the image in quotes. And so when I render that, that's gonna give me another image to show up on the page. So if so far we've talked about kind of creating these elements from scratch, right? How we create a header or a paragraph or an image. But one of the things that actually makes HTML very unique is this idea that there's kind of family relationships between the different elements. And when we say family, it just means that certain elements are going to belong to other families, sorry, to other elements, or rather, they're a part of other elements. So how does that look like? Well, here we can take a look at another tag format that we're going to see. It's called the UL tag. UL stands for unordered lists. Okay, unordered lists, which basically means that it's a way to make a list of bullet points in JavaScript. And so in this case, the UL tag becomes the parent. And then within the UL tag, you will, for each bullet point you want to make, you basically create an element called a LI element, which stands for list item. And because we have the kind of like the container of an unordered list, which contains many individual list items, we then say that each of those list items belong to the unordered list. Or rather, if the unordered list is the parent container or the parent element, then each of the individual list elements is going to be considered a child element. And the child elements are going to be siblings to each other. So we really go deep in this family tree analysis, but let's take a look at an example of what that looks like in real life. Here, in the code on the left-hand side, we have our body tag, which once again is just a container. And hopefully now you can kind of see how the body tag is the thing that captures all of the other code, and that basically tells me, hey, every other piece of HTML lives within the body. The first line of the body is the h1 tag, which just has the text list in it, and that basically means make a big header called list. On line 3, we have our UL, our unordered list element, and then on line 6 there, notice how we have the closing tag for the UL. So between line 3 to line 6, that's going to be the container for our unordered list. And then inside of that unordered list, And notice the indentation here. This tells us that every list element, every ly element on lines 4 and 5 belongs to the unordered list. Whenever an element is part of another element, that we indent the inner elements just to kind of show the relationship. So when we take a look at the code, it's very clear right away which element belongs to which parent, or which child belongs to which parent. And so here we have an unordered list element with two list elements, one list item called 1 and then one list item called 2. And if I take a look on the right hand side then of what this looks like from a family tree perspective, we have our body tag, which is kind of like the huge overarching container. The body contains two elements. There's the H1 element as well as the UO element. The H1 contains the text list, so you see that going down the left-hand branch of the family of the body tree. On the right-hand side, we see the unordered list parent have two child elements. Each of them is called ly, or a list item, and then one of the list item has the text 1, and then one of the elements has the text item 2. Okay, and so this is basically what every piece of HTML we write can basically map into, is that it maps into this tree that tells us which element belongs to who, and then both today and tomorrow we'll kind of understand why it's important that we say that these elements belong to this parent or vice versa. Have I lost anybody yet? Is this clear to folks so far? Okay. So this just is another thing I wanted to kind of show you, is that if I look at the code on the left hand side and the right hand side, they both say the same exact thing. The only difference is lines 2, 3, and 4 are indented on the right hand side, but not on the left hand side. Why is it important? If I look at the code on the left hand side, it's not immediately clear to me as a reader which parent belongs to which child or vice versa, right? If I look on the right hand side of the code, it becomes very clear right away, because of the way the code is indented, that the h3 tag as well as the two paragraph tags, they all belong to the div element. And I know we haven't talked about divs yet, but divs are going to be the most common element that you probably see on most modern websites. And all divs is that it's a blind container. It just contains other elements. And so it's kind of like body in that regard, that it just contains other elements. And so the code on the left, both code are going to render correctly. They're going to show up on the computer correctly. It's just the code on the right is considered better code because it's easier to read and more clear. Okay, so the next thing we'll talk about are block and inline elements, which have a lot to do now with, so we've created the elements, right, by writing the tags themselves, and we've already started mapping out a kind of this idea of the relationship between the different elements through this parent, child, and sibling relationship. Now we'll take a look at the positioning of the elements. And to do that, we need to understand the difference between block elements and inline elements. On the left-hand side, I've written a snippet of HTML, right? It's two p tags side by side. Both p tags have the text hello inside of it. But when I show this on a web page or on a website, notice how in this case, the two hello piece of hello text, they don't show up on the same line, even though my HTML has them on the same line. The two hellos show up on different lines. On the other hand, if I take a look at a tag like the span tag, which once again is another new tag that we're seeing, all a span tag is it's the same as a paragraph tag, except the only difference is here I have two span tags I put on different lines, but when I show them up on the web page, notice how the two text hello and goodbye, they both show up on the same line. And so this is a huge, so this highlights the difference between what we traditionally consider to be inline elements versus block elements. And the difference is that block elements are elements that say, I will take up the entire width of the page, regardless of whether or not I need it, right? So the P tag was a great example of, sorry, the H1 tag was a great example of this that we saw earlier, right? For the H1 tag, even though the words dog breeds takes up less than half of the width on the page, the H1 tag says, I'm going to reserve the entire line's worth of space, and regardless of whether I actually need it. So in this example here, both the H1 and the H3 tags are what we call block tags because they basically block off the entire line of text, even if they don't need the space. On the other hand, we have our span tags, which in some ways are just like paragraph tags, except they're what we call inline tags. Inline tags means that they only take up the space that they need to show their content. And so here I have three span tags in a row, each listing out a breed of a small dog. But all three tags end up showing on the same line because as an inline element, you only take up the amount of space that you need, and you try to kind of squish together and make as much fit on one line as possible. Now, if I had another span tag here with the name of a dog that doesn't fit that line, then yeah, that new span element will go on to the next line, right? But as a kind of a general rule of thumb, what inline elements will say is I will only take up the width of the space I need on the page, and a block tag says give me the entire row first. If I need more, I'll take it, but give me at least the entire row. And so yeah, and so when we talk about positioning and spacing, it'll become very important to make sure that you understand whether or not you're using a block tag or an inline tag. The last thing we're going to talk about here in terms of kind of new kind of concepts around HTML is something called attributes. What attributes are is they are basically additional pieces of information that we can add to an HTML element. And that's pretty important for us because one of the things that you're going to see both today and tomorrow is a lot of times you're going to have dozens, if not hundreds or thousands of HTML elements on the page. And it makes it really important for us to know exactly which element we're talking about when we start writing code for it. And so with HTML, one of the two of the attributes or extra pieces of information we can add are going to be ID and class. Okay, and the way we add an attribute is just like we see on the slide right there. In our open tag, we can just do P and we can put a space there, and we can write the name of our attribute equals and then the value of the attribute, whether it be a string or a number. Okay, so here in my HTML, in my open P tag, I have an ID that just says that's equal to the string just me. Beneath it, I have another P tag, except now instead of calling ID, I call it class. And I set it equal to all of us. Well, what does ID and class mean, and why are we trying to add it in different ways? ID and class are special attributes in HTML, and by convention, what ID says is saying, hey, look, if you think about an ID, think about it like a social security number. It's very unique only to you. Okay, and so in this case, in this HTML, for this P element, when I add an ID to this element, that ID value should be unique to only that element. So only that P tag should have the ID just me. And so the use case for it is if I ever want to select just that element, I would call it by its ID. I'll talk about what it means to reference something by the ID. On the other hand, on the line beneath it, if I want to group a bunch of elements together and I want to have some way to say, hey, I want to talk about these three things together all at once, well then I would just add the class attribute. And what the class attribute does is that it doesn't require that value be unique. And so in fact, I can have other elements also with the same class. And if I want to refer to that group of elements together, I could just look up the elements by the class. And so here I have two different elements, both with two different P elements. It could be different elements too, but they all have the class value of all of us. Yeah, sorry, one more. Now there's three of them. Okay. And so ID, once again, is a way for us to add extra information and extra ID to an element on the page, but just know that ID should be unique to each element, whereas the class attribute, you can assign a value that you can copy and paste across as many elements as you want, as long as your goal is to group all of those elements together in some way. The last two things we'll talk about with regards to new tags is we also have our link tag, which is denoted by A, the A tag. So on the top half of the page, on the left hand side, notice how the A tag has an attribute called href. The href basically tells us when I click on the link on the page, where should that page take me to? Okay, what's the URL of the website that link should take me to? And then the text in between the A tag is basically what shows up as the actual link itself. And so when I look at the right hand side now, the text I want to show up on the page is called visit Google exclamation mark. But when I click on Google, I wanted to take me to wherever the href is has the address linked to. All of these tags we're going to offer a more robust explanation of in the workshop today. So don't worry too much about memorizing for now. Just make sure that at a high level, conceptually, you understand what these tags are trying to do. And then last but not least, we have our old friend, the image tag, the self-closing tag. Notice how there's no separate closing tag, it's just opens, and we give it a src attribute. All the src attribute is saying is, hey, where is this image located? And once we know where the image is located, our tag can end right there because we don't need to give it any additional text or any more information that has to do with how it renders directly. Okay, we are able to add extra things to the image tag to change the size or the coloring or something. We'll talk about that more when we get to the CSS portion. But just know that the image tag only requires one attribute, and that's going to be the source or the location of the image on your computer. Any questions up to now? Cool. So to close off then, just some quirks we should know about HTML. The first one is that white space doesn't matter. And what I mean by that is, on the HTML side, what HTML is going to kind of do for you behind the scenes is, whenever it sees multiple spaces, if it sees one space, it will recognize that as a space. If it sees two or more spaces in a row, what it's actually going to do is it's actually going to take all those spaces and it's going to condense them into one space for you. Right? And so what that means is, when you write HTML, make sure to note that just because you write something differently with white space, it doesn't mean that those changes are going to be rendered or reflected on the web page itself. Right? So writing hello space world is the same as writing hello world with 20 spaces in front of it. Or if you want to put an empty space before or after the text, those also get stripped out too. And so here, even though I'm writing the HTML in 3 different ways, they all show up as the same exact element on the page itself. Similarly, if I have 2 elements and I put them on different lines or on the same line, it doesn't matter to JavaScript. It will render it the same exact way. Remember what we talked about earlier. The only way to control how an element renders, whether multiple elements render on the same page, on the same line or on different lines, and is based on whether or not those elements are inline elements or block elements. Right? How you write the code does not reflect how you render it. It's the properties of the code that you write that determines how the code gets rendered. And then the second thing is, just know that HTML can be very forgiving and sometimes a bit too forgiving. And what we mean by that is, HTML will never tell you that you're wrong. It will just do its best to render what you've written on the web page. And so a lot of times you might think that that's a good thing, but remember the first thing I told you, right? Computers are bad at ambiguity. It will take its best guess, but it may not be correct. And so because of that, a lot of times when you run HTML code, the code will never say, hey, this looks wrong. The code will just always run and do its best to figure out what's happening. But that's why when you write HTML, it's always so imperative that you always look at your output just to make sure that it passes kind of the naked eye test, right? That it looks right, because the code, once again, the code will by design not ever tell you that you're wrong. And then the last but not least, one of the things we'll cover for every language is this idea of how to write comments in that language. Comments are essentially code that is meant for other humans who read your code to see. The computer essentially skips over comments, and comments do not affect how your code runs, nor will it affect how your code renders, right? It's just a way for you to leave a note in the code to other human programmers. And so with HTML, there's many ways to write comments, including this one, which basically says, hey, my open tag is going to be a open caret exclamation mark dash dash. I can write as much text I want in between those, and as long as I close off that comment with a dash dash greater than caret sign, it's a single tag, right? So single tag, but I can write as much text as I want in between those two things, and the computer will just completely ignore it. And so only a human can read that text and can read the text in between those two tags, but the two different tags will render as if the comment was never there. So in this case, we get hello followed by world. Some common mistakes that people make when they first start off writing HTML. The first one is they forget to close tags or quotes. It does happen, and so it's fine to. Sometimes it's better just look at the code and make sure you're kind of dotting your I's and crossing your T's, so to speak. But it happens more often than you think. And once again, remember, HTML will not tell you that you're wrong. It will just try its best to make do with what you give it. Misspellings, another very common error, and this is just a matter of kind of being familiar and being comfortable with the material after a while. And then the last one is failing to indent properly. Remember, HTML will not run because you didn't indent properly, but when you don't indent properly, it does make your code a lot harder for other humans to read. And so making sure that you're indenting your code properly is a great way to make your code seem more professional and more easy for other folks to work with. Okay, so it was a lot, I know, and in the course of the workshop, we'll be doing a review on a lot of these materials. But are there any questions so far before I break us off into the groups?